Very good evening, my dear students. Welcome to Spectropy. Today, let us try to understand how easily we can solve the questions from MSET or NEET or JEE, even though you are in 6th grade or 7th grade or 8th grade or 9th grade, whatever. We take a simple concept as part of the discussion here at demo classes, and let us observe the questions first. Here, if you observe this question asked in 2022, 7th July, MSET Shift 1, AP MSET, the number of significant figures in the quantity 0.00005041 joules. This is a simple question. Observe another question. The number of significant figures in the quantity 5.6200 joules. This question is asked in the same session, same shift for the MSET, but July 11th. Again, if you observe, there is another question, what is the number of significant figures? It is in previous year 2021 from the same AP MSET. This is September 7th. 3.20 plus 4.80 times 10 to the power of 5. Here also how many significant figures? Again, if you observe, this question is again from the same 2022 July 4th. Just in the same July month, whatever the online exams are conducted from the AP MSET, we have from the same simple concept, we have these kind of the questions. Here, A value is given, B value is given and C value is given. We need to compare the number of significant figures between A, B and C. It has that much importance for the competitive exams. Now, you and me together, we understand the concept and also we are able to solve the problems. I will ensure that you also can solve. Please stay tuned with me. Let us start the topic. What is meant by significant? Significant figure means what? The figures are the numbers which are meaningful. So before going in detail about the significant figures, let us understand what is measurement. See, to measure something, always we compare. Suppose if I want to measure the size of this board, I will measure something like this. Let us say this is my comparing unit, reference unit. So let me take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, let us say. So 10 pens. Always we compare one quantity which we want to measure with a standard quantity which we take as a reference. This is the simple idea. Let us take a simple example of the measurement of the rod which I show here. So it is a rod, I want to measure it. Let me take a scale which is centimeter scale where I have only centimeters available. So when I compare this with this scale, I have measurement which is between 4 and 5. Up to 4 I am sure. Up to 4 I am sure. What is the length of this rod? Yes, definitely I can say it is 4 plus something. So this 4 is the certain digit here. What is that? Certain digit. We know that. And after 4, how much is there? I don't know. It may be 1 or it may be 2 or it may be 3. So I can say this is 4. Let us say 1. This measurement, if you ask me, I will say something like 4.1. So in measurement, how many digits are there? One certain digit. 4 is certain and 0.1 is uncertain. Whether it is 0.1 or 0.2, even I don't know. I may see like from here if I see 4.1. So from this side if I see, it looks like 4.2. Even with the parallax error also it may get a difference. So the 4.1 or 4.2, but the measurement is 4 point something. So up to 4 we know certainty, and that 0.1 or 0.2 is the uncertain. So the number of digits which are certain, the number of one uncertain digit altogether can give you measurement. So the number of those digits which are certain plus one uncertain digit, it is called significant figures. So in this case, how many significant figures? 4 and 1, total 2. 4 is 1 digit and 1 is 1 digit. So we have 2 significant figures. Suppose if I take Another way, suppose if I measure, with this if I measure, I may get 4 point something. So if I take another scale, let us say millimeter scale, and compare here, let me take this one where I have millimeters also. So in this case, if you observe, I have the data for, or I can say up to this 40 mm's and 41, 42. So I have 42 millimeters point. Again it is between 2 and 3. So 42 point something, it may be something like 42.3. In this case, 42 millimeters are certain and this 3 is uncertain. Total how many significant figures? 2 certain digits, 1 uncertain digit. So total significant figures 3. 1, 2, 3. If I take another scale, again still it may take a different value. So here the main idea behind this one is, in any measurement there will be certain number of certain digits and 1 uncertain digit. Certain number of correct digits which are very correct and certain, and uncertain 1 figure. So that 1 figure uncertain and plus these certain figures, it depends on the value which is given. So this is about significant figures. And there are certain rules how to identify the significant figures. The rule number 1 will give you all non-zero digits are significant. Remember, rule number 1 always give you all non-zero digits are significant. If I take an example 123.56, how many non-zero digits are here? 1, 2, 3, 4, 5. So 5 significant figures. Suppose if I give you rule number 2 as all zeros between non-zero. All zeros between non-zero. 1, 2, 3, 4. They are non-zeros. And zeros between non-zero. 2. So 4 plus 2 how much? 6 significant figures. And we have rules other than this one also. Suppose if you have trailing zeros after decimal place. Trailing zeros after decimal point, they are also significant. Suppose if you observe 3.5 centimeter has 2 significant figure, 3.50 how many? 1, 2, and after decimal point we have trailing zero. Trailing zero means what? Rightmost digit. Rightmost digit. Rightmost zero or rightmost digit, it is trailing digit. And here how many trailing zeros? 2, and already 2 non-zeros, so total 4 significant figure. We have this much of confusion in significant figure. To avoid that we have shortcut technique, don't worry. It now just I am discussing concept only. And we have a special case, exact measurement. What is meant by exact? Counting. Suppose if I ask you how many students are there in the class, you may say like 25 students. So that 25 students figure, do you have any uncertainty? No uncertainty. We have only certain, exact. So in such case, the significant figure is infinity. Very, very important. Please keep in mind. Let me take an example here. How many apples are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. Up to how many? Once observe here, total 16 apples are there. So in this case, 16 exactly. After 16, you can keep n number of zeros because it is exact measurement. So now it may take even infinity also. So this is the special case in the significant figures. So now how many significant figures in this case? Infinity. Please keep in mind. Now coming to the another kind of the things like continuation to this concept, shortcut technique. So before going to shortcut technique, we have a note here. Once a measurement is done, remember, significant figures will be decided according to closeness of measurement. Okay, and note, if we want to display the measurement in some different units, please remember significant figures will be conserved. It will not change. Suppose if you convert the one measurement from SI system to CGS system, or kilometers to centimeters, or kilometers to micrometers, whatever the change in unit, still you must maintain significant figures same. So that is important thing here you need to consider. Now final, and for which we are waiting, shortcut technique to solve these kind of the questions. So from spectroscopy, we have developed a shortcut technique. Yesterday also we delivered one demo class on shortcut technique for the rounding of figures. Now today we have the shortcut technique for these type of the questions. Once observe, shortcut. Always remember, whenever you get a question, significant figures, you must remember to add a plus b plus c. So what is meant by A, what is meant by B, what is meant by C? Suppose if you observe this question, here in this question, what is A value? What is B value? What is C value? Just if you add all these three values, you are going to get the answer. So now let us know what is A, what is B, and what is C. So the A means find non-zero digits. What is A? A is number of non-zero digits. And coming to B, B is 0 between non-zero, that is B. And in the case of C, C is a special case. C is applicable only in case of decimal numbers. Only in the case of decimal. Remember, only if it is a decimal number, then only this C is applicable. Otherwise A plus B only. C is optional. Remember, if it is a non-decimal number, simply you can say C is 0. So this is a simple technique. Significant figures means A plus B plus C. Now let us observe the question. My dear students, please maintain the notes from this onwards. How many significant figures are there in the measurement 343 grams? So what is the first step? Find A. What is A? Number of non-zeros. How many number of non-zeros? 1, 2, 3. So 3 non-zeros are there. And next, B value. B is number of zeros between non-zero. Do you have any zeros? There are not at all zeros available. So simply you can say B is 0. And C is applicable only if you have decimal number. Do you have decimal number? No decimal number. Simply you can say C is not applicable. So what is our significant figure formula? A plus B plus C. What is A? A is 3. So let us take 3 from there. And plus, what is B? B is 0. Let us take 0 from here. And next, C value is not applicable. So I can say 3 plus 0 is 3. So 3 is my final answer. Now let me take another measurement. How many significant figures are there in 6000 meters? And our rules are A is non-zero, B is zeros between non-zero. Okay. And C is rightmost zeros only if it is a decimal number. Now let us assume A is only one non-zero. So this is 1. And B is 0 between non-zero. If you observe, there are zeros, but they are not between two non-zeros. For all these 3 zeros, you have left side one non-zero. Do you have any right side non-zero? No. That is why B value I can say 0. And C is not applicable. Simply you can say 0 C value. So now finally, significant figures A plus B plus C. What is A value here? 1 plus, what is B value here? 0 plus, what is C value? 0. So 1 plus 0 plus 0, final answer 1. Next, another question. How many significant figures, this is the decimal number, please keep in mind, 0.5000 kilograms. Dear students, if you want to answer this question, you can raise your hand and give me answer. A value, B value and C value. Anybody? You can try. Yes, what is A value here? A is the number of non-zero. How many non-zeros are there? Only 1. So A equal to 1. And B is number of zeros between non-zero. Do you have any number of zeros between non-zero? No. So you can simply say B value is 0. And C, is it applicable or not? First check it. As it is a decimal number, it is applicable. In case of decimal number, what is C? Rightmost zeros. How many rightmost zeros do you have? 1, 2, 3. So total 3. So C value is 3. Now significant figure formula A plus B plus C. What is A value? 1 plus, what is B value? 0 plus, what is C value? 3. So now we have 1 plus 0 plus 3 which is equal to 4. This much simple. Let us take one more question. I hope you are enjoying the session. Now, how many significant figures? This is scientific measurement. In the case of scientific notation, my dear students, please keep in mind, we consider only this one. We neglect this one. Only this one, 1.124. And how many non-zero? A value 4, 1, 1, 2, 4. And B, there are no zeros. So simply I can say B is 0 and C is 0. So the final answer is A plus B plus C. A value 4 plus B value 0 plus C value also 0. So finally answer is 4. Probably last example. How many significant figures? 0.0080 volts. Now A value non-zeros only 1. B value zeros between non-zero again 0. C value, what is C value? C is applicable only in case of decimal number. What is decimal number here? Yes, it is a decimal number. C is applicable. If this is a decimal number, how many rightmost zeros, trailing zeros? Only 1. So C value equal to 1. So now you can consider this one. A value 1 plus B value 0 plus C value 1. So total 1 plus 1 how much? 2. This is an idea behind this one. Now let us come to our regular questions, our previous questions from the EAMCET, from the simple concept. Now let us see. The number of significant figures in the quantity given 0.00005041 joules is, and our working formula for this one is, first find out A. What is A value? How many non-zeros are there? 5, 4, 1. Total how many non-zeros? 3. So A value is 3. And B equal to zeros between non-zero. How to identify it qualified or not? For this 0, right side non-zero is there but left side no non-zero. So for all these zeros, you have right side but left side no non-zero. And for this 0, you have left and right, both are non-zeros. So only one number is there, that is 1, 0. So we can say B value is 1. And coming to C, it is applicable if it is a decimal number. Yes, it is a decimal number. In the case, how many rightmost zeros? There are no rightmost zeros. So C value is 0. So now my SF formula, significant figures. A plus B plus C, that is 3 plus 1 plus 0, which is equal to 4. So the right answer is B. Simple. This is EAMCET question. I hope the students who are in 6th or 7th or 8th and 9th, irrespective of the class, by understanding this concept, definitely you can answer the questions from EAMCET or NEET or JEE main. Now let me take another question. Yes, can you try? Shreyas. Okay. Now second question. The number of significant figures in the quantity. It is asked in 2022 online EAMCET. So now identify what is A value, Shreyas?
3.
Yes, A value is, we have 1 non-zero 5 and 6 and 2, total 3. Very good. A equal to 3. Now coming to B, what is B? Zeros between non-zero. Do you have any zeros between non-zero? No. So B is?
0.
Say loudly.
0.
0. Now coming to C, is C applicable or not?
Yes, it is.
Yes, C is applicable as it is a decimal number. And in the case of decimal number, for C, what is the concept for C? Rightmost zeros, trailing zeros. So I can say how many trailing zeros are there for C? Once observe, 1 and 2. So total 2. Now the formula is A plus B plus C. This is the shortcut which is provided by spectropy to solve the problems in the competitive exams regarding significant figures. So A plus B plus C, what is A value? 3 plus B value 0 plus C value 2. So 3 plus 0 plus 2, that is 5. So the correct answer is B. Now let me take another question. What is the value of significant figures in this case? Now just try to perform this one. If you add these two, according to yesterday concept, it must follow in the case of addition least decimal. Here 2 decimals, here also 2 decimals. So the answer also should contain 2 decimals. Those who missed the yesterday's session, you please contact us. We will provide you the recorded version. Now 8.00 into 10 power 5. And here again a value is 1. B value, it is not applicable because there are no zeros between non-zero. So B value is simply 0. And finally C whether it is applicable or not. If it is a decimal number, then only C is applicable. As 8.00 is a decimal number, so C is applicable. If C is applicable, what is the C? C is rightmost zeros. How many rightmost zeros are there? 1 and 2. Two rightmost zeros are there. So C value is 2. Now the total answer is 1 plus 0 plus 2, which is 3. This much simple. The competitive exams are not difficult, but they are different. And you must manage the time as well as your aptitude skills. Whatever the reference book you refer for this concept, I hope definitely you find this technique is really time saving technique to solve such questions. Let me take another question. Now, if NA, NB and NC values are given, here it is somehow time consuming question, because here you need to calculate significant figures for 3, not a single value. What is NA, what is NB and what is NC? Let us take, coming to the NA, A value, how many for A value? Just observe, yes, A value, let me take the writing part. Okay, for A value, what is the A number of non-zero? 3 plus B value only 1 plus C 0. So this is NA. What is NA value? 3 plus 1 plus 0, 4. Okay, coming to the NB. Now A value 1, 2, 3, 4 non-zeros plus B value, there are no zeros between non-zero, so 0. C is applicable only if it is a decimal. It is not a decimal number, so 0. So total answer is 4. And is it required to solve the one more? Not at all required, because in this case it is NA equal to NB. How many options are there with NA equal to NB? But NC we don't know. Even once observe, NA, NB, yeah, NA, NB equal to NB. Only one option, and NC must be equal. So this is the right answer. Let us cross check it whether NC is also 4 or not. Now 1.200. So what is the A value for NC? A value is 2 plus B value is 0. And C, it is a decimal number, rightmost zeros. How many zeros? 2. So 2 plus 0 plus 2, 4. Hence it is proved. So this is the beauty of the physics. How you see towards the physics, that will create the sense in your mind. If you see it as a smart subject, definitely you will enjoy. If you see it as a difficult subject and fearful subject, then you cannot get the problem solved. So my dear students, please stay tuned with Spectropy, take the enrollment and enjoy your classroom experience. Here, learning is entertainment in our Spectropy. We always enjoy the learning. We don't take much strain. That is why we are offering limited coaching per week. Only 3 quality sessions. In each session, you will get physics 1 class, chemistry 1 class, maths 1 class. So per week, you are getting 9 classes. Along with your regular homework from your school, without getting more pressure on your homework, we are taking limited session alternative days. And for offline students, we are providing continuous homework support also. For online students, you will get the support of only foundation coaching. And our doubt solving window is open to all online all the time, 24/7. Whenever you post the question, you will get the reply from our faculty. Still, if you have any queries, you are free to reach us.